So autonomous vehicles is a very important area of research, not just in terms of self-driving cars, but in other industries, such as avionics, so planes and drones, in agriculture, in terms of self-driving tractors, and in haulage for self-driving trucks. And there are lots of different vehicles being developed across Europe in both industry and academia. The Phantom project is a collaborative research project with partners in the United Kingdom, Greece, Germany, Italy, Spain, Portugal, France, and Belgium. Robots and other autonomous systems have got very complicated computing platforms, a lot more complicated than the sort of normal systems that you'd find in a laptop or maybe a mobile phone. And the reason for this is they have lots of different parts inside that need to be dealt with by domain specialists, and so this makes programming them very difficult. And that's what we're trying to do in the Phantom project. We're trying to make them much easier to program. Phantom lets you write your application in a generic format for putting onto these complex platforms, and then give alongside it an indication for how you want it to run and what you want to optimize. Do you want it to use less power, or do you want to take one specific task and make that run as fast as possible? In this application, this robot platform has a sensor on the top called a LiDAR, which is a spinning laser beam. And the laser measures the depth of an arc in front of the robot. Now this gives it a lot of data, which it then wants to turn into a map of its surroundings, and it does this using a technique called simultaneous localization and mapping. Now this is a complicated technique and uses a lot of computational power. So with the Phantom project, what we're doing is allowing the robot to optimize itself to reduce the amount of power that it uses doing this task. And with this, we've been able to reduce its computational power usage by about 50%, which means that it can move further and that it can map for longer. So obviously we're showing this here on a small robotics platform, but we'll also be testing the same work on aerodynamics calculations for cars in supercomputers and on satellite imaging.